Myself Ravinder from Basic Chemistry Honors Final Year. Today topic is terpenoids of organic chemistry. 10.8 Introduction. The terpenoids form a group of compounds, the majority of which occur in plant kingdom. Isolation of these substances form the various part of this plant, even form a wood in some cases by steam distillation or the ether extraction gives what are known as essential oil. These are widely used in perfumery, food, flavoring and medicine or as a solvent. Among the typical essential oils are those obtained from the cloves, roses, lavender, citronella, peppermint, camphor, sandalwood, cedar and tetrapine. The constituent of essential oil, which are obtained from the sap and tissue of certain plants, are and these were originally called terpenes. However, these days the more general name terpenoid is used, the reason being that the suffix "in" signifies unsaturated hydrocarbons and hence, as such, the name terpene is inappropriate to include compounds such as alcohol, aldehyde, ketones, etc. However, the term terpene is now used only to represent hydrocarbons with molecular formula C10H16. 10.9 Isoprene rule. The thermal decomposition of all terpenoids give isoprene as one of the product. Terpenoids heat gives isoprene plus other product. This suggests that the skeletal structure of all naturally occurring terpenoids are made up of isoprene units. This is called isoprene rule and was first pointed out by Walsh in 1887. This divisibility into isoprene unit may be regarded as a necessary condition to be satisfied by the structure of any natural terpenoid. Thus, according to modern definition, terpenoids are hydrocarbons of plant origin having the general formula C5H8N, where N is equal to 234 etc., as well as their oxygenated, hydrogenated, and dehydrogenated derivatives. In 1925, it was pointed out by Ingold that the isoprenes in natural terpenoids were made joint head to tail, the head being the branched end of the isoprene unit. This divisibility into isoprene unit and their head to tail union may be referred to as spectral isoprene rule. The carbon skeleton, open chain monoterpenoids and squiterpenoids showing head to tail union of isoprene units are shown as below. Head to tail bonding. However, it may be pointed out that although this rule has proved very useful, yet it can be used as a guiding principle and not as a fixed rule. Several exceptions to this rule are known. For example, in Levenduol and Evo divided into isoprene unit. 10.10 Classification. We have stated that the most natural terpenoids hydrocarbons have the general formula C5H8N, where N is equal to 234 etc. It is this value of N which is used for a classification of terpenoids as shown below. The sister terpenoids have been discovered only recently. The first example of this class is called sol, an acyclic unsaturated alcohol, which was discovered in 1956. In addition to hydrocarbons in each class, O is given in above table. Oxygenated compounds like alcohols, aldehyde, ketones, etc. are also known, which occur in nature. Each classes of terpenoids has been further divided into subclasses such as acyclic, monocyclic, bicyclic, tricyclic, and tetracyclic terpenoids according as they have open chain structure or have 1, 2, 3, or 4 rings respectively. 10.11 Some representative examples of each class, their structure, source, and chemical characteristics are summarized below. Monoterpenoids, monocyclic, bicyclic, etc. Second, sesquiterpenoids. The terpenoids are classified into four groups according to the number of rings present in the structure. If we use the isoprene rule, then when three isoprene units are linked head to tail to form an acyclic hydrocarbon, the latter will contain four double bonds. Each isoprene unit contains two double bonds, but one disappears for each pair that is connected. When this open chain compound is converted into a monocyclic structure, another double bond is utilized in the process. So monocyclic terpenoids hydrocarbons contains three double bonds. It is similar way it is found to be that bicyclic contains two double bonds that and a tricyclic one. Diterpenoids. Representative example: phytol ablatic acid, phytol C20H40O. It is obtained by hydrolysis of chlorophyll, and it also forms part of molecules of vitamin E and K. It is a cyclic diterpenoids. It has two chiral centers 7 at 7 and 11. Ablatic acid C20H30O2. It is tricyclic diterpenoid. Triterpenoid squalane C30H50 is a acyclic triterpenoid. It has been isolated from liver oils of this harsh. Other sources are olive oil and other vegetable oil. Tetraterpenoids are called carotenoid. For example, beta carotene present in carrots and lycopene, which forms the red pigment of tomatoes. Thank you.